Okay, organizations absolutely need to prevent sensitive data from accidentally leaking or being stolen, whether it's through email, file transfers, maybe even just sitting unencrypted somewhere it shouldn't be. This is where DLP, data loss prevention, comes in, right? What capabilities do these tools offer? They sound like guardians.
Exactly. Data loss prevention, DLP, is a critical suite of technologies designed specifically to prevent sensitive data from being exposed, leaked, or lost, while also helping ensure compliance with various regulations. It acts as a security net for your most valuable information.
A security net, okay.
But a foundational requirement for any effective DLP system, and this is key, is knowing what data is sensitive. This absolutely necessitates robust data classification, which we talked about earlier.
Right, gotta know what to protect first.
Exactly. Without clearly classifying your data, a DLP system is essentially operating blind. It can't distinguish between a public press release and a secret merger agreement.
Okay, assuming classification is done, what does DLP actually do?
DLP tools offer three core interconnected functionalities. The first is discovery and classification.
Finding the sensitive data.
Finding and identifying it, yes, across the organization's entire digital landscape. Scanning data at rest, in cloud storage, databases, file shares, data in motion, traveling across networks via email or web traffic, and data in use on endpoints like laptops.
How does it find it?
Well, DLP systems automate this painstaking process. They use various methods, recognizing predefined templates for common sensitive data types, like IPA or PCI data, identifying specific patterns using regular expressions for social security numbers or email addresses, or leveraging advanced machine learning and AI algorithms to understand the content and context, automatically tagging it as PII, financial data, or IP.
Okay, discovery and classification. What's second?
The second main function is monitoring. This means continuously observing how data is being used, what's moving across the network, and where it's being stored, all in real time.
Watching everything.
Constantly vigilant. DLP systems are designed to detect risks or policy violations as they occur. When a potential issue arises, like an employee trying to email a spreadsheet with unencrypted customer data externally, the DLP system sends immediate alerts to security teams, providing crucial context.
Alerts. Okay. And the third function?
The third, and often most impactful functionality, is enforcement. This goes beyond just alerting to actively block or modify actions that violate policy.
Blocking bad actions.
Right. DLP systems can prevent data from being copied to a personal USB drive, stop an email with confidential info from leaving the org, or prevent unencrypted sensitive data being stored on a public cloud share.
So it can stop things automatically?
Yes. Enforcement can also involve more nuanced actions, like automatically encrypting a file if it contains sensitive data before it leaves the network, redacting specific sensitive info from a document before it's printed, or notifying both the user and admins about a violation and requiring an override. The key is that enforcement needs to be carefully tailored. You need to allow legitimate business use while still restricting risky activities. It's a delicate balance.
Where do these various DLP capabilities typically operate within an organization's architecture? Do they sit in one central place, or are they spread out?
They're definitely deployed strategically across different points in the architecture to provide comprehensive coverage. It's a layered approach, really.
Layered.
Network DLP monitors data in motion as it traverses the network perimeter or internal segments. Think emails leaving, web uploads, file transfers. It often uses deep packet inspection at network gateways, email servers, or proxies to analyze content in real time. You usually need multiple network sensors for full visibility.
Okay, network. What about stored data?
That's storage DLP. It focuses on sensitive data at rest, scanning various data repositories, databases, file servers, cloud storage buckets like S3, shared drives. Its purpose is to find sensitive data stored insecurely, classify it, ensure it's encrypted where needed, enforce access controls. It triggers alerts if, say, it finds unencrypted PII on a public share.
Makes sense. And on people's computers.
That's endpoint DLP. It uses a software agent installed directly on user devices, laptops, desktops, sometimes mobile phones. Its role is to monitor and secure data on the user's device itself, preventing things like copying data to USB drives, printing sensitive docs to unsecured printers, transferring files to unsanctioned cloud services. The agent watches activities and can block actions or send alerts based on policy.
Endpoint agent. Got it. Any other places?
Yeah, a couple more specialized ones. You can have a hypervisor agent for DLP in virtualized environments. This sits at the hypervisor level below the VMs.
Below the VMs. Why?
It allows monitoring and enforcement across all VMs on that hypervisor without needing agents on each VM. Crucially, it eliminates blind spots that network DLP might miss, like traffic moving directly between VMs on the same host, which might never hit the network sensors.
Ah, clever. Inter-VM traffic.
Exactly. And increasingly common is DLP SaaS. This can be built-in DLP functionality within a SaaS app itself, like in Microsoft 365 or Google Workspace, that customers configure. Or it can be a cloud-based DLP solution delivered as a service by a third-party vendor. These cloud DLP solutions monitor data flows and enforce policies between various cloud applications, providing security even when your data is spread across multiple SaaS platforms. This whole distributed, layered approach ensures sensitive data is protected no matter where it is.
How do these DLP tools actually discover the sensitive data across an organization's huge, often messy digital landscape? It sounds like finding that needle in the haystack.
It absolutely is a monumental task. Yeah, needle in a haystack is a good analogy, which is why the discovery methods are so important and sophisticated. You can't protect what you don't know you have, right?
Right.
There are three primary methods DLP systems employ for discovery.
Okay.
First, label-based discovery. This is often the most efficient method if an organization has a robust data classification and labeling policy already in place.
Relying on those labels we talked about.
Exactly. If data has been appropriately labeled, ideally embedded in the metadata, then DLP tools can easily search for these machine-readable labels and quickly identify sensitive information. A document tagged confidential PII. Easy for DLP to find and protect.
Okay. A label-based. What if there are no labels?
Then there's metadata-based discovery. Metadata, remember, is data about data attributes like creation date, author, file format, custom tags. DLP tools can scan this metadata for relevant info that might indicate sensitivity even without explicit labels. For instance, a document created by the legal department with a specific naming convention might be flagged as potentially sensitive based on that metadata.
Okay, looking at the about info, what's the third way?
The third and often most resource-intensive method is content-based discovery. This is where the DLP system actually searches directly through the data content itself for specific patterns, keywords, or contextual indicators.
Looking inside the files.
Looking inside, using regular expressions to find patterns like social security numbers, credit card numbers, phone numbers, email addresses, or searching for specific keywords like confidential, merger agreement, patient diagnosis.
Sounds powerful, but maybe slow.
It can be slower and more computationally intensive, yeah. And it can sometimes be prone to false positives, flagging non-sensitive data, or false negatives, missing sensitive data if patterns aren't perfectly defined. Most mature organizations use a combination of all three methods, labels, metadata, and content, to get comprehensive and accurate discovery.
And when it comes to enforcement within DLP, what's the critical balance between just alerting people to potential violations and actually blocking actions? There seems to be a big trade-off there between security and productivity.
There absolutely is a critical balance, yes. And organizations need to carefully consider their risk tolerance, their compliance requirements, and their operational needs. DLP enforcement can use a rules-based approach via alerts or outright blocking.
Okay, alerts first.
Alerts are a softer enforcement mechanism. They inform users or administrators of potential policy violations without immediately stopping the action. For example, if an employee tries to email a document with PII unencrypted, the system might pop up an alert for the employee, reminding them of the policy, and maybe simultaneously notify a security team.
What's the risk there?
The primary risk is that these alerts might be ignored, dismissed, or just not acted upon quickly enough, which could still lead to a data breach. It relies heavily on human intervention and compliance, useful for education and monitoring, but maybe not enough to prevent leaks.
Okay, so alerts might not be enough. What about blocking?
Blocking, on the other hand, is a more aggressive, immediate enforcement mechanism. It actively prevents the data from being compromised by stopping the action altogether.
Stops it cold.
Stops it cold. If that same employee tried to email the PII unencrypted, the DLP system would simply block the email from being sent, or maybe encrypt the attachment automatically before sending. While blocking offers much higher immediate protection and dramatically reduces risk.
There's a but.
There's a but. It carries the significant risk of false positives.
Blocking legitimate stuff.
Exactly. A false positive means a legitimate business activity is incorrectly identified as a violation and blocked. This can hinder work, frustrate employees, make security seem like an impediment. Imagine blocking a vital report because it contains numbers that look like credit card numbers but aren't. That could disrupt things badly.
So it needs careful tuning.
Very careful and continuous tuning to balance the imperative of preventing data compromise with the need to enable productive business operations. It's a continuous process of refinement to find that sweet spot where security is effective without becoming a bottleneck.
Okay, data discovery. It sounds simple, but it seems to have a few different meanings depending on the context in information security and management. Can you clarify these different uses for us?
You're right. It's definitely a term that pops up in several distinct contexts, and it's important to differentiate them to avoid confusion. One meaning of data discovery, as we just discussed extensively with data loss prevention, is that ongoing process of finding, identifying, cataloging an organization's important and sensitive data across all its systems and storage locations.
The DLP kind of discovery.
Exactly. The primary driver there is security and compliance, knowing what sensitive data you have and where it is so you can protect it.
Got it. What's another meaning?
Another distinct meaning is eDiscovery, which stands for electronic discovery. This is a highly formalized legal process.
Legal process, okay.
It involves identifying, collecting, preserving, processing, reviewing, and producing digital records and electronically stored information ESI that might be relevant to a court case, a government investigation, or some legal proceeding. It's all about forensic investigation and fulfilling legal obligations to present evidence.
Like finding emails for a lawsuit.
Precisely. If your company is sued, legal teams will initiate eDiscovery to find all relevant emails, documents, communications, etc.
Okay, eDiscovery. Is there a third meaning?
And then there's knowledge discovery in databases, KDD, which some sources also broadly refer to as data discovery. KDD is more of an academic and practical field focused on developing methods and techniques for making sense of large volumes of low-level data.
Making sense of data? How?
The aim here isn't necessarily security or legal compliance, but rather to extract useful insights, hidden patterns, actionable knowledge from vast data sets. This is where terms like data mining and business intelligence really come into play, transforming raw, often chaotic, data into intelligent, structured information for business decisions and predictions.
Ah, so finding business value.
Exactly. So while the term data discovery is broad, its specific meaning is almost always clarified by the context protecting data, fulfilling legal needs, or extracting business insights.
So KDD, knowledge discovery in databases. It aims to make sense of huge amounts of data, find patterns, drive business decisions. What are some of the key terms and concepts associated with this process that listeners might encounter?
Yeah, KDD is all about transforming that raw data into actionable intelligence for business decisions, helping organizations understand their customers, markets, operations better. Within this field, several key terms define distinct activities.
Okay.
Data mining is a specific, crucial step within the broader KDD process. It involves using various analytical techniques, statistics, machine learning, AI algorithms to look for patterns, correlations, anomalies hidden within large data sets. It's the engine that finds the nuggets of information.
Finding hidden patterns.
Right. For example, data mining might reveal that customers who buy product A are also highly likely to buy product B. That's an insight.
Okay. What about business intelligence?
Then you have business intelligence, BI. This isn't a single tool, but rather an umbrella term for a set of strategies and technologies that enable businesses to collect, analyze, and gain new insights from data to improve decision-making. Data mining often feeds directly into BI initiatives, providing the insights that BI tools then visualize and report on for management. BI tools help track performance, identify trends, make more informed strategic choices.
So BI uses the results of data mining.
Often, yes. Now, when it comes to where this vast amount of data lives for analysis, two crucial terms are data warehouse and data lake.
Warehouse and lake, what's the difference?
A data warehouse is a central repository, specifically designed for structured business intelligence data. It's highly organized, meticulously cleaned, optimized for quick and easy analytical queries and reporting.
Structured and clean.
Very. Data from multiple operational systems is extracted, transformed, and loaded, ETL process, into the warehouse in a unified, consistent format. Think of it as a highly organized, curated library for specific pre-processed information ready for immediate analysis, often used for historical reporting and trend analysis.
Okay, the White House is organized. What's the lake?
In contrast, a data lake is a repository for all data, whether it's structured, semi-structured, or completely unstructured, stored as is in its native format.
Everything gets dumped in.
Pretty much. Raw data often lands in a data lake first, without undergoing prior transformation. This gives organizations immense flexibility to process and analyze it in various ways later, maybe using advanced analytics, machine learning, AI for predictive modeling, or complex pattern recognition. Some of this processed data might then be moved to a data warehouse for more traditional BI activities.
So the lake is raw, the warehouse is refined.
That's a good way to put it. Think of the data lake as a vast, unprocessed reservoir of all your data, while the data warehouse is a refined, structured, typically smaller subset that's ready for immediate business reporting.
It sounds like the type of data structured, unstructured, semi-structured significantly impacts how easy it is to discover, analyze, and ultimately secure it. Can you break down those differences for us? This seems fundamental.
Absolutely. Understanding data structure is fundamental to effective data management and especially to designing appropriate security controls. Different structures pose different challenges and require different approaches.
Okay, start with structured.
Structured data is highly organized, formatted, and easily processed. Think of it as data that fits neatly into predefined rows and columns, like a traditional relational database of customer records.
Rows and columns, like a spreadsheet or a database table.
Exactly. Each piece of information has a clear, predefined field, customer first name, last name, address, phone number. It adheres to a specific schema or data model. This makes it straightforward for traditional database tools to query and analyze, and for DLP systems to discover sensitive info using precise patterns. It's very predictable, tabular, making it the easiest to manage and secure using conventional methods.
Okay, structured is easy. What about unstructured?
On the other hand, unstructured data lacks any predefined structure or organization. It doesn't fit into neat rows and columns, making it much harder to store, process, analyze with traditional tools.
What kind of data is that?
Examples include the vast majority of human-generated data, emails, Word documents, videos, images, audio recordings, social media posts, free-form text documents.
So most of the data out there.
A huge volume, yes. While challenging, techniques like natural language processing and advanced pattern analysis are used by DLP tools to search for sensitive information within this type of data, like recognizing a social security number in an email body or a credit card number in a PDF. Unstructured data needs special attention because sensitive info can easily fall through the cracks if not properly identified. Poses a significant security risk.
Okay, unstructured is messy. What's semi-structured then?
Finally, semi-structured data sits in between these two extremes. It has some organizational structure, but it doesn't adhere to the rigid, consistent schema of a relational database.
Some structure, but not fully structured.
Right. It often uses tags, labels, or other markers to make parsing specific attributes easier, providing maybe a hierarchical or graph-based structure. Common examples include XML and JSON files, which use tags or key-value pairs to define elements, but don't enforce a fixed tabular schema.
Like configuration files sometimes.
Exactly. While more flexible than structured data, they are still much more manageable than completely unstructured data because there's some inherent predictable organization. For security, identifying sensitive data in semi-structured formats often involves parsing these tags and looking for patterns within the defined fields.
Given all these different data types and their complexities, why is data's physical or even logical location so critical? Especially when you're operating in the cloud, it feels like it adds another significant layer of complexity to securing it.
Data location is absolutely paramount. For all phases of data security, especially for DLP impacting discovery, monitoring, enforcement. And in the cloud, yes, this is particularly challenging and often a source of significant compliance headaches.
Why is it so challenging in the cloud?
The primary issue is that many cloud services, especially in the SaaS and PaaS models, offer limited control or visibility over the exact geographical or even logical location where your data resides.
You don't always know where it is.
Not precisely, no. A cloud provider might, for example, replicate your data across multiple data centers globally for resilience and performance. Or they might move it between regions for load balancing or maintenance. Well, that's good for availability.
It messes with compliance.
It can severely complicate compliance with data residency laws. These laws, like GDPR in the EU or various country-specific regulations, often mandate that certain types of data, especially personal data, must stay within a specific country or geographical region. If your data fragment gets replicated to a server outside that region, you could be in violation without even realizing it.
Yikes. So how do you manage that?
The fundamental solution lies in your contractual agreements with your cloud provider. Your contract must explicitly specify the necessary security controls, the geographical locations where your data can and cannot reside, and the compliance obligations the cloud provider commits to for data on their infrastructure.
Get it in writing.
Absolutely. You need to ensure they have the right technical and organizational controls in place to protect your data wherever it's located, and that those specified locations align precisely with your organization's regulatory requirements and business needs. Without clear contractual terms and regular auditing, you might inadvertently find yourself out of compliance simply because you don't know or can't control where your data is actually being stored or processed. It's all about contractual assurance and due diligence when direct physical control is limited.
We've mentioned data classification a few times now as being super important for enabling effective security controls and really understanding your data. How do organizations actually set up these classification systems? What does it involve beyond just sticking a label on something?
Yeah, classification is indeed the backbone of informed data protection. It ensures that valuable assets receive the appropriate level of security and, frankly, resource allocation. Now, while we frequently use the shorthand data classification, it's more accurately understood as asset classification.
Asset classification, not just data.
Correct. It encompasses anything of value to the organization, not just digital data, but also human resources, physical buildings, IT equipment, software code, intellectual property, and of course, the various forms of data itself. The overarching aim is to ensure all these diverse assets are protected appropriately based on their true value, sensitivity, and criticality to the business.
Okay, so protecting all valuable assets. Where do you start?
The very first foundational step is to create a robust and comprehensive asset inventory. This is essentially a detailed catalog or listing of absolutely everything of value across the entire organization. It's about gaining visibility into everything you own and need to protect.
Catalog everything. Then what?
Then the next crucial step is to assign ownership. Every single asset needs a clearly defined owner. This owner is the individual or role ultimately accountable for that asset's protection, its integrity, its availability.
The accountable person.
Right. They are best positioned to determine the asset's true value to the organization, its business criticality, its sensitivity, the potential impact if it were compromised. This understanding then directly dictates its appropriate classification level. An owner might be a department head for their team's data, or maybe a C-level executive for sensitive corporate IP.
Okay, inventory and ownership. Then comes the policy.
Then comes the data classification policies. These policies meticulously stipulate the different classes or categories of data an organization will use. For example, defining levels like public, internal use only, proprietary, confidential, or maybe highly confidential.
Defining the levels.
Defining the levels. And crucially, these policies also explicitly outline how data assigned to each class should be controlled and protected across its entire lifecycle. These policies provide a quick, simple, uniform way to decide on and consistently implement security controls across the organization, ensuring everyone understands the baseline requirements.
And how do you decide on those levels and controls?
Well, how you define and apply these classification levels fundamentally depends on your organization's unique circumstances. Things like the inherent value and sensitivity of the data, the specific type of data, PHI, credit card details, any applicable regulatory obligations, HIPAA, GDPR, PCI DSS, the data's ownership, and who's authorized to use it. These factors collectively determine the security requirements for each classification level. Hashtag classification and categorization. Just to further clarify a couple of terms here. Classification refers to the system of classes itself, the predefined categories, typically ordered by value or sensitivity that an organization establishes, like top secret, confidential, restricted, unclassified. Organizations define these based on their specific risk appetite and regulatory landscape.
A system of levels. Okay.
Categorization, on the other hand, is the act of assigning or sorting individual assets, a document, a database, a server, into one of these predefined classes.
Putting things into the levels.
Exactly. So the system is the classification, and the act of labeling an item with a class is categorization. Subtle distinction, but important for clarity in policy and procedure. Hashtag data labeling.
Once data is classified and we've categorized it, how do people and, automated systems actually know what class it belongs to? It seems like it needs to be clearly identifiable for consistent handling.
Right. Once data is classified and categorized, the information about its assigned class is communicated through data labeling. This means including a label that is somehow attached to the data itself, clearly communicating how it must be handled and protected throughout its lifecycle. Makes the classification actionable.
Labels. Okay, are there different kinds?
There are two main types, serving distinct purposes. A security label is machine readable. It's typically embedded within the data structure or associated metadata. Automated systems like DLP tools, access control systems, archiving solutions can read these labels programmatically to apply controls and policies without human intervention. Enables automated enforcement.
Machine readable for automation. Got it.
The other type is a security marking. This one is human readable. It's often visibly placed on physical storage media, like a hard drive or USB stick, or prominently displayed in the header or footer of a digital document, on presentation slides, maybe in email subject lines.
For people to see.
Exactly. Its purpose is to clearly inform any person handling the data about its classification and the required handling procedures. For example, a document might have confidential stamped prominently on every page.
What kind of information goes into these labels or markings?
Well, these labels are incredibly important because they convey crucial context about the data without revealing the sensitive data itself. They can include a wide range of important info, the specific class or classification level, like confidential, relevant dates, creation, modification, retention, destruction dates, the owner, usually by role or office, like HR, department data owner, the source where the data came from, applicable jurisdiction and regulatory requirements like subject to GDPR, details about access, who's authorized, under what circumstances, and finally, specific security controls that should be applied, like encryption requirements or sharing restrictions. All of this labeling information, and often much more, is frequently part of the data's metadata. Metadata is literally data about data.
Data about data.
It's a collection of characteristics that describe a given piece of information, providing essential context and facilitating its management, discovery, and security.
Can you give some examples of metadata?
Sure. Think of an email. The actual data is the email body and attachments. The metadata for that email would include things like the time and date it was sent and received, the sender and recipients, the subject line, its size and file format, crucially, its classification label if assigned, any attachments it might have, even context-specific traits like the location where a photo was taken, GPS data, or the type of camera used.
So all the descriptive stuff around the actual content?
Exactly. Metadata is incredibly powerful for automated discovery and management because systems can process these descriptive characteristics much faster than analyzing the content of every single file. It's what allows DLP systems to quickly identify sensitive files based on their labels or origin, or for archiving systems to apply retention policies based on creation dates. It essentially makes data smart and self-describing, which is vital in complex dynamic cloud environments.
Okay, so once people have legitimate access to sensitive documents, how do organizations control what they can actually do with that content? It's not just about who can open a file, right? But what actions they can perform once they're in. This sounds precisely like information rights management, or IRM.
That's precisely what information rights management, IRM tools, are designed to do.
Yes.
They represent a sophisticated layer of security that extends beyond simple access control.
Okay.
IRM includes powerful mechanisms engineered to prevent unauthorized viewing, modifying, copying, printing, forwarding, or even deleting files and information. Their primary goal is really to keep sensitive business information confidential and ensure it's used only as intended, even after it has left the immediate control of the server or the sender system.
Even after it's sent somewhere else.
Exactly. For example, in enterprise environments, IRM can protect sensitive corporate documents, spreadsheets, emails. It allows you to share them with collaborators while still retaining granular control over their use, preventing a recipient from forwarding a confidential email or printing a sensitive contract, for instance. Hashtag IRM versus DRM.
Now, there's also something called digital rights management, or DRM. What's the distinction between DRM and IRM? They sound very similar in their objectives.
They do sound similar, and while they involve similar underlying technologies and concepts of controlling access and usage, their focus and typical application differ significantly.
Oh, so?
DRM, digital rights management, primarily protects copyrighted material from unauthorized access, copying, and distribution. Its most common applications are in consumer-facing content. Think movies, music, ebooks, software.
Stuff you buy online.
Right. DRM enforces usage policies defined by the content creators or distributors. For example, it might dictate how many times you can play a movie, restrict printing an ebook, prevent copying music files, limit software installations. It's largely a business-to-consumer technology aimed at preventing piracy and ensuring content creators can monetize their work.
Okay, DRM is for consumer content protection. What about IRM then?
IRM, Information Rights Management, on the other hand, is considered a subset of enterprise DRM, but its focus is much more narrowly on controlling sensitive business documents and emails within an enterprise environment.
Internal business stuff.
Exactly. It applies fine-grained, persistent access and usage controls directly to the document itself. So while DRM aims to protect mass-market content for the general public, IRM focuses specifically on internal corporate documents, intellectual property, confidential communications, trade secrets, ensuring they remain protected even when shared with authorized individuals, both inside and outside the organization. It ensures your internal sensitive data isn't easily leaked or misused. #tag types of intellectual property.
IP. Beyond just sensitive data in general, organizations also have various forms of intellectual property, or IP, to protect, which can be incredibly valuable assets. What are the common types of IP that IRM might help secure within an enterprise?
Intellectual property, yeah. IP is indeed one of the most valuable assets for many organizations today. And IRM often plays a crucial role in its protection within the enterprise. There are 4 common types recognized legally.
Okay, what are they?
First, trade secrets. These are types of IP that derive economic value because they are not generally known or readily ascertainable by others outside the organization.
Like the Coke formula.
Exactly like the Coke formula. Or a unique recipe, a proprietary manufacturing process, a confidential customer list, a secret algorithm giving a company a competitive edge. The protection for trade secrets is potentially infinite, lasts as long as it remains secret and you take reasonable steps to protect it. But if it leaks or is independently discovered, the legal protection is lost.
Okay, trade secrets need secrecy. What's next?
Second, patents. Filing a patent grants the owner the exclusive right to prevent others from building, selling, or using an invention for a set number of years, typically 20 years from filing.
But you have to reveal the invention.
Yes, unlike trade secrets, patents require public disclosure of the invention in detail in exchange for that limited time monopoly. Designed to foster innovation by making knowledge public eventually, but letting the inventor profit first.
Okay, patents, third.
Third, copyright. This grants the owner the exclusive legal right to copy, distribute, display, or perform a creative work.
Like books, music, software.
Right. Books, music, films, software code, photos, architectural designs. Copyright protects the expression of ideas, not the ideas themselves. Also has a set period, usually life of the author plus 70 years. For software companies, protecting source code via copyright is absolutely critical.
Makes sense. And the last one?
Finally, trademarks. These are designs, logos, symbols, phrases, expressions that uniquely distinguish a brand, service, or product from others. Think famous logos, product names, jingles. Trademarks can have potentially infinite protection as long as they continue to be used in commerce and are properly maintained.
So how does IRM protect these?
Well, while IRM is specifically designed for documents and emails, these types of IP are frequently contained within those digital assets. A document describing a trade secret, a software design document protected by copyright. IRM becomes a critical control for their protection in the digital realm. #tag IRM objectives and capabilities. The core objective of enterprise-grade IRM, really, is to facilitate the authorized sharing of company data while simultaneously limiting unauthorized access and use. It's about enabling controlled collaboration, ensuring sensitive data doesn't end up where it shouldn't.
Controlled collaboration. Okay.
IRM meticulously defines data rights. These are the granular, permitted actions an authorized user can take with a given asset. Much more precise than simple read or write. Includes actions like creating, viewing, modifying, copying text, printing, forwarding, deleting.
Very specific permission.
Very specific. Provisioning involves the process of accurately determining and then maintaining which of these specific rights a user should have, strictly adhering to the principle of least privilege, only granting the absolute minimum access essential for their tasks. Minimizes potential impact if an account is compromised.
Least privilege. Always important.
Always. When designing an IRM implementation, you also critically consider the access models, precisely how the protected data will be accessed and consumed. Could involve encrypting files and sharing keys only with authorized users, or using secure web apps that enforce granular controls based on user roles and context.
How it's accessed.
Right. Appropriate tools are essential. These are the software solutions allowing authorized access while imposing barriers to unauthorized use. Microsoft's Rights Management Services, RMS, or Adobe Acrobat's document security features are familiar examples offering robust IRM.
Okay. And how is it enforced?
For enforcement techniques, IRM systems use different mechanisms. Online reference checks might require users to authenticate in real time with a central IRM server to get a key or permission. Allows dynamic revocation of rights. Alternatively, a local IRM agent can be installed directly on user devices. This software agent authenticates the user and checks authorization directly on the device, often enforcing policies even when offline for a limited time.
Okay, online checks or local agents. What specific controls can IRM provide?
IRM provides incredibly specific, granular controls over actions, often hard to restrict otherwise. For instance, it can prevent users from copying and pasting text from a protected document into an unprotected app, taking screenshots of sensitive content, printing, forwarding, or sharing documents without explicit permission, editing or modifying content beyond what's allowed. It can even set an expiration date, automatically revoking access after a certain date or time.
Wow, very granular. Does it track usage too?
Absolutely. IRM systems enable comprehensive auditing of access and use. They meticulously track and monitor how protected documents are accessed and what actions are performed, who opened a file, when, what actions like printing, editing, sharing. Creates an essential, immutable audit trail for accountability and forensics.
Essential for investigations.
Crucial. Furthermore, IRM can incorporate signing sealing, digitally signing documents for authenticity, integrity, non-repudiation, and encrypting documents, sealing, to enforce the defined IRM policies persistently, embedding controls within the file itself. Most powerfully, IRM systems can enforce these specific access permissions based directly on a document's classification, ensuring a highly confidential document automatically gets much stronger protections than a public one, streamlining policy application. # Cloud DRM Challenges.
Okay, even with all those powerful IRM capabilities, protecting digital content in the cloud must present its own unique set of challenges, especially given the inherently distributed and shared nature of cloud environments. What are the specific hurdles organizations face there?
You're absolutely right. Cloud environments, while offering immense benefits, introduce specific and often complex challenges for IRM and DRM in general. The very nature of DRM and IRM relies fundamentally on the concept of a trusted environment.
A trusted environment.
Yeah, an environment where you have full, unquestionable control over the infrastructure, where the content resides, and where it's being accessed and processed.
But in the cloud, you don't have that full control.
Exactly. In the cloud, while you're leveraging a provider's infrastructure, the cloud provider themselves has access to that underlying infrastructure. This creates a fundamental dependency on these third-party providers to safeguard your content and enforce your IRM policies at the infrastructure level.
You have to trust the provider.
You do. You are, in essence, relying on their security measures, their operational integrity, their ability to prevent breaches or insider threats from their own staff. This dependency can significantly complicate your security posture because you don't have the same level of direct physical and logical control you might have in your own data center.
So the provider relationship is key.
It becomes an even more critical component of your overall IRM strategy. You must have confidence in their ability to maintain the trusted environment in which your rights management operates. Requires due diligence and strong contracts.
Okay, data doesn't last forever, or at least it probably shouldn't unless there's a very good reason. What happens when data is no longer actively used, but maybe still needs to be kept for compliance, or ultimately needs to be disposed of securely? This seems like a complex area, managing data's end of life.
You've hit on a crucial phase of the data lifecycle.
Yeah.
One that many organizations definitely struggle with. When data falls out of active day-to-day use, organizations face a critical decision. Should it be securely destroyed, or should it be retained for a period, perhaps in an archive? This involves very careful policy formulation, balancing legal obligations, potential business value, and the often significant costs associated with long-term storage and security.
So policies are key here.
Absolutely. This is precisely where robust data retention policies come into play. They are foundational. They dictate precisely what types of data must be kept, for how long, and in what format, primarily to meet legal, regulatory, or industry-specific obligations.
Like keeping financial records for 7 years.
Exactly. Financial records often has strict 7-year periods. Certain health records might need to be kept for decades. These policies also meticulously specify when data can transition from active storage to a less expensive archive, and crucially, when it must be securely destroyed using appropriate, verifiable methods that prevent recovery.
What else should these policies cover?
Well, important considerations go beyond just legal mandates. They must also define the security requirements for retained data, because archived data is still sensitive data. They need to ensure clear procedures for retrieval access when that data is eventually needed, maybe for an audit or legal discovery. And a very important aspect, one that can override all normal retention periods, is a legal hold.
Legal hold, you mentioned that.
Right. This is a directive that requires specific data to be preserved if it's relevant to an ongoing or anticipated legal case or investigation. Organizations need robust, proactive mechanisms to identify and preserve such data, even if its normal retention period would have already expired. Failing to implement a legal hold correctly can lead to severe legal penalties. ## data retention challenges.
Retaining data in the cloud. It certainly sounds like it could simplify things compared to managing physical archives in-house, maybe cheaper. But what are the specific challenges and nuances of keeping data for long periods in a cloud environment?
While retaining data in the cloud does offer significant benefits, potential cost efficiency compared to managing large in-house hardware archives often provides built-in scalable backup solutions. Several specific challenges remain that demand careful attention.
Okay, like what?
First, retain data. Even if it's moved to a cold or archived storage tier, still needs robust security. It's not out of sight, out of mind. It must be continuously protected from unauthorized access, accidental modification, or loss throughout its entire retention period, which would span many years. This means applying encryption, access controls, monitoring even to data that's rarely accessed.
Security doesn't stop just because it's archived.
Never stops. Second, regularly tested backups are absolutely essential, even for archived data. Data in long-term cloud storage still needs to be recoverable in case of an incident, accidental deletion, malicious act, rare cloud provider outage. You need to verify that your recovery processes actually work. Don't just assume.
Test your backups, got it.
Third, the entire retention system itself needs rigorous auditing mechanisms. You must be able to prove compliance with your policies and regulatory mandates, demonstrating the data is being retained exactly as required and destroyed precisely when its retention period expires. Crucial for accountability.
Proof of compliance. Okay.
And finally, long-term retention requires considering how you will secure and access that data even as technology evolves over time. What if the file format becomes obsolete in 10 or 20 years, making the data unreadable? What if the encryption algorithms used today are no longer considered secure in the future? These are long-term strategic factors that need to be built into your retention strategy. ## data deletion procedures and mechanisms. Media sanitization.
Okay, deleting a file. Just hitting delete or moving it to the trash often isn't enough, is it? How do we ensure data is truly gone and unrecoverable, especially from storage media, and not just hidden or marked for deletion? This is where media sanitization comes in, right?
You're absolutely right. Simply deleting a file often just removes the pointer or reference to it in the file system, leaving the actual data blocks on the disk, making them recoverable with readily available tools. That's why media sanitization is critical. It refers to the comprehensive process of securely disposing of data from storage media in a way that ensures it cannot be retrieved or reconstructed by any means. NIST Special Publication 888, a widely recognized standard, outlines 3 categories for this, offering increasing levels of security against recovery.
3 categories. Okay, what are they? From worst to best?
Right, from worst to best in terms of recoverability. The first category is clear. This uses logical techniques to sanitize data, providing protection against simple, non-invasive recovery methods. While it prevents casual recovery, data may still be recoverable with more advanced forensic techniques.
So clear isn't foolproof. What techniques are used?
Techniques here include simple deletion, removes link, not data. Overwriting, writing new data over old, but old data is still potentially recoverable. Erasure wiping, a more formalized overwriting, often with zeros or ones. And reformatting puts an empty file system on the device, but old data often remains.
Okay, so clear is basic. What's the next level up?
The next level is purge. This applies logical or physical techniques to make data recovery infeasible using state-of-the-art laboratory methods. The data cannot be reconstructed by any known technology. This is a much higher level of assurance.
Infeasible? That sounds much better. How do you achieve purge?
Techniques in this category include more advanced forms of multipass overwriting and erasure, often with verification steps, cryptographic erasure, crypto shredding, which we'll talk more about, and degaussing, which involves exposing magnetic media like hard drives or tapes to a strong magnetic field, scrambling the data. Degaussing makes the data unreadable, but often renders the media unusable too.
Okay, purge is strong. What's the ultimate level?
The highest level is destroy. This level ensures that data recovery is rendered infeasible, and critically, it makes the media itself permanently unusable for data storage. This is the most secure method for eliminating data.
Physically destroying it.
Exactly. Techniques involve physically destroying the media so it cannot be reused. This includes incineration, burning, pulverization, grinding, disintegration, breaking into small fragments, shredding, mechanically cutting, melting. Degaussing can also fall here if it renders the media unusable. The choice depends on data sensitivity, media type, risk tolerance. For highly sensitive data, physical destruction is often preferred when possible. #tag cryptographic erasure, crypto shredding.
Okay, cryptographic erasure or crypto shredding. That sounds like a very clever way to destroy data in the cloud, especially since, as a cloud customer, you often can't physically destroy the provider's hardware. How exactly does that work, and why is it so effective in this cloud context?
You've precisely identified why cryptographic erasure, or crypto shredding, is so incredibly important and prevalent, particularly in cloud environments. It provides a robust purging method when physical destruction of the underlying media just isn't an option for the customer.
Makes sense. So how does it work?
The core principle is that the sensitive data is first encrypted with a very strong encryption algorithm. This encryption uses a unique, strong encryption key that your organization controls. The data then resides on the cloud provider's storage in its encrypted form.
Encrypt first. Got it.
Right. The critical step for erasure, or shredding, then involves securely and irretrievably purging that encryption key.
Get rid of the key.
Get rid of the key completely and permanently. Securely delete it from all locations, including backups, key management systems. If that key is gone, well, the encrypted data, even if it physically remains on the cloud provider's storage media, becomes unreadable and effectively unrecoverable.
Because you can't decrypt it without the key.
Exactly. Without the key, the encrypted data is just random noise. It's as good as destroyed unless the encryption algorithm itself is broken. Highly unlikely with modern, strong algorithms. Or the key could somehow be brute forced, practically infeasible for robust keys.
So it's a logical destruction method.
Precisely. It's highly effective as a purging method because it addresses the fundamental challenge in cloud. You don't have physical access to the provider's media to shred or degauss their drives. Crypto shredding allows you to achieve a purge level of sanitization through a logical process you control, without needing to touch the physical hardware. It shifts the point of destruction from the media to the key. Powerful and often the only practical option for secure data destruction in shared cloud infrastructure, data archiving procedures and mechanisms.
Okay, so if we're not destroying data, but it's no longer in active use, it goes into archive. What's the goal here for archiving, and what are the typical procedures and considerations for organizations? Is it just about saving money?
Archiving is a crucial phase.
Yeah.
For the long-term storage of data, there's no longer an active, day-to-day operational use, but still needs to be retained. The key distinction is that archive data is still available, still retrievable, but typically access is much slower and, critically, much cheaper than active high-performance storage. So cost is a factor, but not the only one. It's about cost-effective long-term preservation.
Okay, cheaper and slower access. Why else is archive?
Well, there's several key reasons. First, often strict legal and regulatory obligations require retaining certain data for a set period. Financial records, healthcare data, communications logs. Archiving ensures compliance.
Compliance makes sense.
Second, the data may still hold significant long-term business value. Not needed daily, but may be invaluable for future analysis, historical trending, audits, strategic planning. Think historical sales data for predicting future trends.
Finding insights later.
Right. And third, archiving is often a highly cost-effective way to store backups, especially for disaster recovery. Older backups can be moved to cheaper archival tiers while still being recoverable if needed.
Okay, compliance, future value, backup costs. What about policies?
Your organization's archiving policies must meticulously account for all these factors. They need to define the exact retention periods for different data types, the sensitivity of the data, which dictates security controls even for archived data, and the specific procedures for how data will eventually be destroyed or sanitized at the very end of its archival period. This includes defining retrieval procedures, ensuring data, even in a cold archive, can be accessed within defined SLAs if an urgent need arises, like that legal hold we discussed. It's a distinct phase needing its own policies, tech, and careful management. #tag legal hold.
And finally, that very important consideration that can potentially override all those normal data retention and destruction policies, legal hold. What exactly is that again, and why is it so critical for organizations to have processes in place for it before they actually need it?
Legal hold, sometimes called litigation hold, yes, it's an absolutely crucial consideration for data retention and destruction. And it's a non-negotiable legal requirement. If an organization becomes involved in a legal case, a government investigation, or even anticipates such action, data relevant to that case immediately becomes subject to a legal hold.
Freeze everything relevant.
Essentially, yes.
Yeah.
It's a directive, usually issued by the legal department, to preserve all potentially relevant electronically stored information, ESI, regardless of its current state or any pre-existing data retention policies.
Overrides normal deletion schedules.
Completely. The implication is profoundly significant. Your organization may be compelled by law to find, collect, and provide specific data related to the case. Critically, you will be prevented from sanitizing, deleting, or destroying that data, even if its normal retention period would have already expired according to your internal policies.
So you must keep it.
You must keep it. For example, if your standard policy says destroy emails after 3 years, but those emails are identified as relevant to an ongoing legal case, they must be preserved indefinitely until the legal hold is officially lifted.
Which means you need a way to do that.
Exactly. You need robust mechanisms and clear procedures in place before a legal case arises. These procedures must enable you to quickly and accurately identify, preserve, and retrieve specific data on demand across your entire IT landscape, including cloud environments. Failure to comply with a legal hold can result in severe penalties, hefty fines, adverse legal rulings, sanctions, even charges of obstruction of justice. It's all about proactive preparedness for potential legal challenges. Ensuring your data management practices are resilient enough to handle these sudden, mandatory shifts in retention requirements.
Okay, finally. How do organizations effectively keep track of who accesses data, when they access it, and precisely what they do with it? This level of insight is absolutely crucial for security investigations, for demonstrating compliance to auditors, and for holding individuals accountable, especially in the cloud where direct visibility can sometimes be, well, challenging.
Right, this is the realm of auditability, traceability, and accountability. And it's fundamentally about creating a clear, undeniable, and comprehensive trail of evidence for every significant event within your systems.
A trail of evidence.
Exactly. By systematically logging events, meticulously recording who accessed sensitive data precisely when they did it, what specific actions they performed, viewing, modifying, deleting, you build an essential audit trail. If a security incident, a data breach, even a system malfunction occurs, you can then trace back through these logs to determine responsibility, understand the exact sequence of events, analyze the root cause, and take appropriate action.
Essential for response and compliance.
Absolutely. This capability not only aids in rapid incident response, but it's also critical for meeting compliance requirements, demonstrating due diligence to regulators, and fulfilling legal obligations. #tag definition of event sources and attributes. Now, to build an effective audit trail, you need to understand logs deeply. Logs are essentially records of events, which are activities recognized and recorded by a system. For security purposes, we meticulously log relevant activities, particularly suspicious or security-critical ones.
So what makes a log entry useful? What needs to be in it?
For each logged event to be useful and attributable, it must include a specific set of critical event attributes. Identity. Who or what performed the action. User ID, username, process ID, system ID. Without clear identity, accountability is impossible. IP address, the IP address of the user, system, or service initiating the event. Helps pinpoint network location. Geolocation. Geographic location, ideally from GPS or inferred from IP. Critical for detecting anomalous access.
Okay, who, where, network, where, geo, what else?
Timestamp. The exact date and time the event occurred, including milliseconds, synchronized across systems for accurate sequencing. Event type. Clear description of the action. Example, login success, file deleted, access denied. Source system. Which system generated the log? For example, firewall, database server, affected resource. The specific data, file, system, or app targeted. And result, whether the action succeeded or failed.
That's a lot of detail per event.
It is. Each event should ideally have a unique event ID and other pertinent info depending on its type, creating a rich context for analysis. The more granular and detailed your logs are, the more powerful your auditability and traceability become. #, logging, storage, and analysis of data events.
So it's not just about collecting these detailed logs from countless systems, but making sense of the sheer volume of data streams coming in. How do organizations manage this immense influx of information and effectively spot potential threats or anomalies hidden within it all?
You're right, the sheer volume is immense. Data streams from users, applications, servers, firewalls, infrastructure across a modern organization. It's staggering. Manually sifting through this volume and spotting subtle threats or malicious patterns is virtually impossible, like finding that needle in a continent-sized haystack.
So automation is needed.
Absolutely essential. This is precisely where SIEM systems, security information and event management, become vital tools. They are specifically designed to automate the collection, secure storage, and sophisticated analysis of vast amounts of log data from across your entire enterprise environment. Think of them as the ultimate needle in the haystack finders for security.
SIEMs. Okay, what do they actually do?
SIEM systems possess several key capabilities. First, aggregation. Collecting event data from incredibly diverse systems, firewalls, OSs, apps, databases, cloud services, network devices, bringing it all into one central location. Unified view.
Pulling it all together.
Then, normalization. The SIEM cleans up the disparate event data, transforming it into a consistent, comparable format regardless of the source. Essential because different systems log info differently.
Making it all speak the same language.
Pretty much. After that comes correlation. This is where the real power lies. The SIEM analyzes incoming logs from multiple systems in real time for logical sequences, specific patterns, indicative values to identify complex events invaluable to individual systems.
Connecting the dots between systems.
Exactly. For example, a single failed login might be normal, but 100 failed logins from different geographies in a short period, followed by an unusual file access attempt, that could strongly indicate a brute force attack. The SIEM correlates these seemingly unrelated events.
Finding the bigger picture. What else?
SIEMs also provide secure storage for log data over the long term, crucial for meeting regulatory and policy requirements for retention and ensuring log integrity for forensics. Their analysis capabilities involve applying various techniques, event correlation rules, statistical models, behavioral analytics, even machine learning to detect errors, anomalies, potential threats deviating from baselines, or known attack patterns. When something suspicious is detected, the SIEM generates reporting alerts, dashboards, detailed reports for security analysts to investigate. And crucially, SIEMs require continuous updates and optimization tuning to adapt to evolving threats and system changes. Ongoing refinement is key. Auditing and logging challenges in the cloud. Now, the cloud definitely introduces its own specific set of challenges for logging and auditing that organizations need to meticulously navigate. Important considerations.
Okay, cloud-specific challenges, like what?
One significant challenge is limited customer access. As a cloud customer, especially in SaaS environments, you often have restricted access to the underlying infrastructure logs. The provider manages nearly everything. While they might provide application logs or API access logs, you typically don't get deep system-level logs from the hypervisor or physical servers.
So potential blind spots?
Definitely potential blind spots.
Yeah.
IaaS offers more control, more visibility into your VMs and networks, but it's still not the same level of granular access as a physical server in your own data center.
Okay, limited access. What else?
Another major challenge arises in multi-provider environments. Many organizations today use multiple cloud providers simultaneously, maybe one for SaaS, another for PaaS, a third for IaaS. Your SIEM system then needs to be incredibly sophisticated, capable of ingesting, normalizing, and correlating logs from all these disparate providers to construct a truly cohesive security picture.
Stitching together logs from different clouds?
Right. Without this aggregation and correlation, you end up with fragmented visibility. Major security risk makes incident response far harder. And finally, don't forget cost considerations. Generating, storing, analyzing vast amounts of log data in the cloud can get expensive quickly. You pay for storage, egress, compute for analysis. Selective logging and efficient SIEM configuration are crucial for managing expenses too. Chain of custody and non-repudiation. Revisit it.
We touched on non-repudiation earlier, and it sounds like robust logging plays a very big part in proving actions in a legal context, especially after a security incident. Can you elaborate on how logging supports non-repudiation and also that critical concept of chain of custody?
Indeed. Robust, immutable logging provides foundational evidence for investigations, bolstering both non-repudiation and establishing a verifiable chain of custody, vital for legal defensibility.
How does it help non-repudiation again?
Non-repudiation, remember, prevents someone from plausibly denying an action. In digital systems, this is often done with crypto, like digital signatures. The logs provide the undeniable factual record, a detailed, time-stamped, unalterable entry showing who, what, when, where an action occurred. If someone digitally signed a doc, the system log records that action and the signature is the crypto proof. Combined, they make it extremely hard to falsely deny involvement, invaluable for accountability.
Okay, logs provide the record. What about chain of custody?
Chain of custody is crucial, specifically for legal or forensic cases. It's the meticulously documented proof that demonstrates precisely how evidence, like log data, has been collected, preserved, handled, analyzed, and eventually provided to courts or investigators.
Documenting the evidence handling?
Exactly. This documentation ensures the integrity and authenticity of the evidence throughout its entire life cycle, showing it hasn't been tampered with, altered, or substituted. For instance, if log files are used as evidence in a data breach investigation leading to legal action, a meticulous chain of custody ensures those logs are accepted as legitimate, reliable, untainted records by a court.
So the evidence is admissible.
Right. Without a clear, unbroken chain of custody, even highly probative evidence, like detailed logs, can be challenged and potentially dismissed. Undermines your case. Together, robust logging, strong non-repudiation mechanisms, and scrupulous chain of custody practices create a powerful framework for security, compliance, and legal defensibility, especially in the complex landscape of cloud computing.
Wow. We've covered a huge amount of ground today in CCSP Domain 2, from those fundamental concepts like confidentiality, integrity, and availability, all the way to the intricate details of data loss prevention, tokenization, and critical data lifecycle management. Understanding these aspects is absolutely crucial for protecting data in any cloud environment.
Absolutely. And remember, securing data in the cloud isn't just about isolated technologies. It's really about building a holistic strategic defense that considers every phase of data's life, every role involved, and every potential threat vector. This comprehensive knowledge really empowers you to build truly robust and resilient data defenses.
If you enjoyed this podcast, don't forget to like and subscribe to our channel and check out our CCSP playlist.